My name is Iman Carson, and my topics were the three states of matter in the periodic table. The three states of matter are going to be solid, liquid, and gas. A solid has definite shape, definite volume, and its particles are going to be very closely packed together. A liquid is going to have definite volume and definite shape. Its particles are closely packed together as well, but not as closely as a solid. And a gas is going to have indefinite shape and indefinite volume. Its molecules are going to be very far apart. The periodic table was created by Dmitri Mendeleev. It is separated into periods and groups. Periods are the horizontal rows and the groups are the vertical columns. Here indicated in the black are going to be the metals. They're on the left side of the periodic table, and the zigzag line on either side are going to be metalloids, which are elements that have properties of both metals and nonmetals. On the right side are going to be the nonmetals. The main groups are going to be alkali metals, group 1, alkali earth metals, group 2, halogens, group 7, and noble gases, group 8.
Hi guys, my name is Michael and I'm here to talk to you about chapter 3, which deals with stoichiometry. I'm here to specifically talk to you about the mole. The mole is the SI unit for the amount of substance of something, and it's unique because it represents not only the mass of a particular substance, but the number of atoms in it as well. To get to moles, we are usually given either grams of a substance or the number of atoms of a substance. If we start with grams of a substance, we simply divide by the molar mass to achieve a mole. The molar mass is given on the bottom of an element on the periodic table. Once a mole, we achieve a mole, you can multiply by Avogadro's number, which equals 6.022 times 10 to the 23rd. To equal the atoms in that particular substance or the number of entities. I'm here to talk to you about chapter 4, which deals with the polar nature of water and its role as a solvent. Solvent is defined as the larger amount of substance which is solute, the smaller amount of substance is dissolved in. Water plays a unique role as a solvent because it is a polar molecule. This means that it has an unequal distribution of electron charge. This is because the H plus ions are partially positively charged while the O ion is partially negatively charged. When H2O is used as a solvent with an ionic compound, the electron attraction of the compound itself is weaker than the electron attraction of the ions themselves to the oppositely charged ends of the H2O molecule. Thus, the ionic compound dissociates and becomes solvated, and each ion floats around in an aqueous form in the solution.
Hi, my name is Raul. First, I got chapter 5.6, and it deals with the behaviors of gases. So in order to determine the behavior of gases, we use the ideal gas law. The ideal gas law is PV equals nRT, P being the pressure, V volume, T temperature, and for moles, and R equals the ideal gas constant, which is this number, 8.3145. The only reason we would ever use the ideal gas constant is under STP, which is standard temperature and pressure. But because gases don't always behave the way they should, this guy named van der Waals came up with a totally new equation where A and B are constants, and those are for specific gases. And basically it just accounts for different gases, the way they would behave. There's two postulates when dealing with gases. The first one states that gases have volumes that are determined by the size of their atoms as well as the direction and lengths of their bonds. And two, that there are indeed attractive and repulsive forces at work amongst gas particles because of the presence of a charge. So that's what this equation right here will, it will follow the two postulates. Now if it goes back to where there's standard temperature and pressure, basically this equation right here will just revert back to this one, which is the ideal gas law. Roll again. Okay, so right now I'm doing chapter 6.2, which discusses enthalpy, and what I'm really focusing on is the change in H, which is the change in enthalpy. The equation for that is the products minus the reactants, which is H final minus H initial. What this can tell you is it can tell you whether the process is either exothermic or endothermic. If the products are less than the reactants, then the process is going to be exothermic, which means it's going to release heat. And then if the products are greater than the reactants, it's going to be endothermic, which means it's going to absorb heat. So what the change in enthalpy does is basically just tells you the change of heat in a certain process and how much heat is being either absorbed or released.
Hi, my name is Amber Lehman. Today I'm going to be focusing on Chapter 7. the nature of light. There are four main qualities that light has. That's going to be amplitude, wavelength, speed, and frequency. Frequency is the number of waves that pass a certain point in a second. For example, the one on the bottom is going to have a much higher frequency than the one above it. Wavelength is going to be the distance from one tropical wave to the next, or one crest to crest. This is going to be measured in meters and is represented by the symbol lambda in equations. Amplitude is the distance from the center of a wave to the crest, or the center of a wave to a trough. This deals with intensity. A wave with a higher amplitude will also have a higher light intensity. Speed of light in the vacuum is always the same number, 2.998 times 10 to the 8th meters per second. You can find the speed of light by multiplying wavelength times frequency. Since the answer will always be the same no matter what, the two must be inversely related, meaning that as one of them goes up, the other will go down.
Amber again, and now I'm going to be talking to you about Chapter 8, Periodic Trends. Pretty much there are three main periodic trends. It's going to be electron affinity, ionization energy, and atomic size. Atomic size can be found by having the distance between the nuclei of two atoms. In main group elements, atomic radius tends to increase down a group and decrease across the period. Ionization energy is defined as the energy needed to remove 1 mole of electrons from 1 mole of atoms in a gaseous state. It is inversely related to atomic size, meaning that it will decrease down a group and increase across the period. Electron affinity is the energy associated with the addition of 1 mole of electrons to 1 mole of atoms in a gaseous state. Similarly to ionization energy, electron affinity will also increase going up a group and increase going across a period.
Hello, my name is Eric Campos, and I'm going to talk to you all about electronegativity. According to the text, electronegativity is the relative ability of a bonded atom to attract shared electrons. For instance, on the periodic table, they are arranged perfectly where the electronegativity actually increases from left to right, and it increases from the bottom up. So francium has the lowest electronegativity with a 0.7, and fluorine has 4.0, and basically fluorine has 7 electrons, francium has 1, and it needs to fulfill the full octet, so francium is going to give off its electron, and fluorine is going to take electrons. My name is Eric, and I'm going to talk to you all about Chapter 10, Molecular Polarities and the Behavior. And I'm going to choose the molecule water, since it's very common and very easy to choose. And basically, it's going to have 3 atoms, 2 hydrogens, and 1 oxygen, and the 2 hydrogens need 2 electrons, so that's shown by the bond that they have, and then the oxygen needs 8 electrons, and so the extra electrons go at the top of oxygen. And if you can just picture a big cloud right here, and basically this cloud is where the electrons roam, and hydrogen wants to go that way, but it can't, since the electrons are pushing them away, making it bent. And this bent formula that we have here is very important to the world as we know today, and the polarity of water is very vital to our life.
Hi, my name is Alfredo. My topic is hybrid orbitals. When molecules bond covalently, the central atoms sometimes combine their valence shells to maximize efficiency. This process is called hybridization and involves combination of a certain amount of s, p, or d orbitals. sp hybrid orbitals are formed from one s and one p orbital combining to form 2 identical sp orbitals. These orbitals form a linear molecular shape. sp2 hybrid orbitals are formed from 2 p orbitals and 1 s orbital combining to form 3 identical sp2 orbitals. These orbitals form a trigonal planar molecular shape, or a bent shape if it has 1 lone pair. sp3 hybrid orbitals are formed from 3 p orbitals and 1 s orbital combining to form 4 identical sp3 orbitals. The molecular shapes formed are tetrahedral if there are no lone pairs, trigonal bipyramidal if there is one lone pair, or bent if there are 2 lone pairs. sp3d hybrid orbitals are formed from 1d, 3p, and 1s orbital combining to form 5 sp3d hybrids. Because a d orbital is required, the central atom must at least be a period 3 element. The molecular shapes formed are trigonal bipyramidal if there are no lone pairs, seesaw if there is only one, T-shape if there are 2, or linear if there are 3. sp3d2 hybrid orbitals are formed from 2d, 3p, and 1s orbital combining to form 6 sp3d2 hybrids. The molecular shapes formed are octahedral if there are no lone pairs, square pyramidal if there is one lone pair, or square planar if there are 2.